seeking help? Thank you. So Dr. Sharma is going to talk about concussive head injury, how it exacerbates Alzheimer's disease pathophysiology. Dr. Sharma, take it away.
Thank you so much for this opportunity. This is an honor for me to showing some results to you from our research group. This is a large research group from, this is Dr. Mureșanu from Romania, Dr. Napiente from Spain, Dr. Asia from the United States, Dr. Tian also from the United States, Dr. Patnaik from India, Dr. Nogari from Harvard, United States, Dr. Mosler from Austria, Kaskelani is also from the United States, and Sharma, my wife, is from the United States. So this is a collective work together. We are working for a long time. I have nothing to disclose, except I tell you that this is my personal opinion, all the results and conclusions. It has nothing to do with any government organizations with whom we are working. Military personnel are quite vulnerable to Alzheimer and Parkinson's disease. The basic reason is that probably mild to moderate traumatic brain injury or a stress associated with the job. And there are lots of results and research can be found. Alzheimer's disease is quite prevalent in many parts of the world, including the United States, and so far we have not come across any positive therapy that can reduce the misery of the patients. As you can see that this is mild cognitive impairment and this is Alzheimer's disease. So there is a huge loss of neurons and tissue destruction that is responsible for all kinds of misery in Alzheimer's disease. As you can see here, there is ventricular enlargement and damage to the hippocampus. That is one of the primary reasons for our memory function. And these things are very important in Alzheimer's disease and of course also in Parkinson's disease. I show this as military risk factor for Alzheimer's, dementia and neurodegenerative diseases. Not only traumatic brain injury, but post-traumatic stress disorders. And this is quite prevalent in many of our veterans returning from the war. There are different publications, and some people are doubt about amyloid is the basic region of Alzheimer's disease, but I am not going into this controversy. I am only telling you that amyloid fingerprinting has recently been done and it is published, and I am showing you some of the results if you are not already familiar with it. This is the example of control. You can see amyloid fingerprinting is very little. There can also be in normal cases. This is brain injury and this is dementia, but most surprising aspect of enhanced fingerprinting in post-traumatic stress disorder. So post-traumatic stress disorder has much more amyloid fingerprinting in wide areas in the brain. Now the question comes here again, LD control versus PTSD, post-traumatic stress disorder, and you can see that how this post-traumatic stress disorder is showing amyloid fingerprinting in different areas. So this has something to do with amyloid beta peptide. Now a question comes, where? Do we have homogeneous increase or deposition of amyloid? The author answers that this is not. You can see this is frontal, cingulate, parietal and temporal and occipital cortex. The level of deposition is different, and post-traumatic stress disorder is quite clear here in all the cases, apart from this is TBI and this is TBI plus post-traumatic stress disorder. So these are the factors that can influence much more to the Alzheimer's disease pathophysiology. The question comes that we also have in our plasma healthy animals or humans this amyloid beta peptide. The question is, whether all the stress or traumatic brain injury due to breakdown of the barrier can come from the plasma to the brain? This is one question. Or do we have any plasma factor that influence amyloid beta peptide? This question was answered with this publication, and it's telling that plasminogen, this deposition, is important. Blood plasminogen is sufficient to protect against both innate immune cell activation in brain and Alzheimer's disease. And the authors show that when they have done that, they are able to reduce this Alzheimer's disease pathophysiology. Now, we are working on blood-brain barrier in different kinds of diseases, including traumatic brain injury and Alzheimer. The available evidence is that the efflux of amyloid beta peptide is slowed down also because of the damaging blood-brain barrier. But recently, Dr. Zlokovic, one of the pioneers in Alzheimer's disease, his research and reviews now suggest both ways are possible. And this was one of the examples when in one patient, this is quite old, from 1968 or 69, there is leakage of albumin in one patient of Alzheimer's disease. So the point is that, of course, as we know that blood-brain barrier is the gateway of brain diseases, and therefore the amyloid beta peptide is leaking into the brain also comes from plasma, apart from its efflux is slowed down. We did animal experiments, and you can see here that there is deposition of endogenous serum albumin, and that was not so distinct when we had used a drug called cerebrolysin. Cerebrolysin is a multimodal drug having different kinds of neurotrophic factors and peptide fragments. It is commercially available from Austria, and there are several clinical trials on traumatic brain injury, stroke, and even Alzheimer's disease are going on in the United States of America. So this multimodal drug has protected leakage of serum albumin. So we wanted to understand the pathophysiology of oxidative stress, and also we understood nitric oxide role, and we evaluated mesenchymal stem cells. Our main aim is nano delivery of certain compounds, and do we enhance or exacerbate amyloid beta pathology after traumatic brain injury? So these are the questions we have used, and we used this amyloid beta peptide infusion model that is well established. We used a mild, or for rats one can say moderate, and this was the model. This weight is dropped on the skull, and it produces 0.2 to 4 meter impact on the right side, and we have seen that the left side is much more damaged, so it is producing a counter-coup energy. This is the example here. You can see that the impact was on the right side, and the left side showed much more damage than the left side, than the right side. Sorry. The United States military, I am showing some of the data available with us, and as you can see that over 244,000 cases occurring during a short period of time, 12 years of time. There are also differences with age and male versus female. The point is that this is quite a compact and complex pathophysiology of traumatic brain injury, and it varies with age and male versus female. This cartoon shows that this is the motor planning and processing will be significantly affected after concussion, and as you can see that this is quite clear. So what we would like to study, that influence of some oxidative parameters or free radical generators, and among those nitric oxide is one of the important aspects beside giving cerebrolysin and other drugs. We advocated use of nanotechnology as a therapeutic strategy in Alzheimer's disease earlier, and then single therapy versus combined therapy we are trying to study in a laboratory model. These are titanium nanowires. This is a US patent, and we are working with the University of Arkansas. This is Dr. Ryan Tian and Dr. Ryan. They have the patent, and they are leveling the drugs. Now you can see that even mesenchymal stem cells are nanowired, and they live longer and produce better results than alone. So what we have found, we can see that this is a table. This is blood-brain barrier leakage, brain edema formation, and some of the pathological symptoms, neural injury, amyloid beta deposit, and albumin positive cells. You can see this blood-brain barrier. This is control. You can see that amyloid beta infusion enhances every parameter. See, But when we have given a combination of traumatic brain injury or concussive head injury, we have much more higher values in all the cases. Then we have given nano delivery of cerulizin. This was equally effective in reducing. And also in traumatic brain injury combination, they were able to reduce, but the extent was much less. Then we have delivered nanowire using primary stem cells. You can see they were able to reduce it. And also in traumatic brain injury and amyloid beta peptide infusion, the values were significantly less, but considerably higher. When we have given the combination, you can see that even under traumatic brain injury, the values were considerably lower, means the combination therapy works. Does it also work at the cellular level? Probably the answer is yes. This is untreated means amyloid beta peptide infusion. This is nanowire using primary stem cells. This is nanowire cerulizin alone, but we have seen much more live neurons here than in the combination. Regarding nitric oxide antibody, we have given nitric oxide expression in amyloid beta peptide infusion plus CHI, concussive injury disease control, and more massive expression of neuronal nitric oxide after the combination. And here you can see that nanowire cerulizin alone and the mesenchymal stem cells. Of course, there is some expression of nitric oxide is there. So we can say that pronounced expression of neuronal nitric oxide synthase is also contributing to amyloid beta peptide pathology in making brain injury, and combination therapy is working better. Now, some of the biochemistry that we started to understand what is happening, and I will show you in a tabular form. And here you can see that phospholipid tau, amyloid beta peptide, neuronal nitric oxide positive cells, stored neurons, and number of astrocyte cell activation. Amyloid beta infusion, you can see is increased everywhere. Plus traumatic brain injury, further values are increased. Then we have given nanowire cerulizin, values are reduced. Combination of both, you can see they were significantly lower. And if we added further to neuronal nitric oxide synthase antibodies, the values are still lower. So therefore, nano delivery of drugs in combination can be useful to at least at the experimental model to reduce the pathophysiology of the brain injury following amyloid beta peptide infusion or traumatic brain injury. But I want to give you a caution here that not all drugs given by nano delivery can produce wonderful results, as you have seen some of the questions here. This is a homing test. Some of you might know much better than me. This is the compartment of normal because we are toning. I'm showing this spinal cord injury, and this is the worst untreated. And you can see that some of the nano drug delivery they come into this compartment after a spinal cord injury. Some of them are in this compartment, and some of them come in between. So you have to choose your drugs carefully to give nano delivery to have quite better neuroprotection. The question is still there that why and how nano delivery of drugs can produce superior neuroprotection. To answer this question, we still are working, but the available evidence suggests that in our case, nanowire delivery, the drug can penetrate endothelial cell membrane with tiny holes, and they can be deposited anywhere, intracellular or extracellular spaces. They can release their drugs for a longer time, and since they are bound to nanowires, they may be less susceptible to quick metabolism. These could be one of the factors that probably will have superior neuroprotective effects. Regarding the technological presentation, we have submitted this nitric oxide synthase antibodies in another model with nanowire delivery, and we were happy that this jury found that this is top 20% technological development in the field of combination of nitric oxide synthase antibodies and mesenchymal stem cells here in this case of spinal cord injury. So we believe that these are the experimental states, and we need to further to understand this pathophysiological aspect or toxicological aspects that are underway, because at the moment we are working on titanium dioxide nanowires. And to emphasize those things, this progressive brain research volume on neuroprotection and nano-neurotoxicology, edited by my wife Sharma and me. This will come within 2 months, highlighting some of the examples. Previously, we have done also the nanotechnological advances by Springer, and also the Elsevier International Review in Neurobiology. So we are making some cases for nano delivery of drugs in different conditions. And this is a very large organization, so we have different kind of supports from various organizations. These are my collaborators, and Dr. Saidari is sitting behind. He has introduced us to nanoparticles for the first time, and we are continuing the work. I am from Uppsala University, and thank you very much for your kind attention.
We have time for a few questions. Anybody? Charles?
Since it is a neuroprotection method that it has been administered before the injury happens,
No, all the drugs were given after different time periods after traumatic brain injury or after infusion. Normally, amyloid drug infusion is given for 4 weeks, and we started drug delivering after 2 weeks of infusion. In case of when we have concussive head injury, 4 to 48 hours after nano delivery, and we have seen up to only 48 hours. And the survival period were 72 hours, because that's at the moment we have the limitation of our experimental methods.
Any other questions? I don't see any. I'll ask one. So you show a significant amount of neuroprotection. Does that translate to behavioral outcomes? Have you looked at behavior?
It's a very good question. Yes. We have used rotary treadmill, we have used inclined plane angle test, and also finding platform inside water. And so far in our hand, those drugs that produces better neuroprotection showing improved behavioral function. And but our limitation is only up to 72 hours because of the ethical committee, So we believe that up to 72 hours. I wish I could have 20 months to work on that.
Yes, I think that's a good point. I mean, as Rita showed us, not only looking at long term, but also looking at making sure you have the right test.
Yes.
When she showed early on, you didn't see a deficit, but if you look with the more sensitive tests, you actually do pick them up. And I think that's important for all of us who do behavior after brain injury. We don't want to, for example, miss the benefits of a therapy, for example, because our task is too simplistic. So I think that's important.
Yeah.
Any other questions? So I guess if we have no more other questions, we will end this session. Can we get another round of applause for our experts?